Hello everybody. Now we shall discuss some problems on DC potentiometers. Come to the first problem. A simple slide wire is used for measurement of current in a circuit. The voltage drop across a standard resistor of 0.1 ohms is balanced at 75 centimeters. Find the magnitude of the current if the standstill EMF of 1.45 volts is balanced at 50 centimeters. Solution. What is the voltage drop per unit length? For the length of 50 centimeters slide wire, you're going to have 1.45 volts. That is, the standstill EMF of 1.45 volts is balanced at 50 centimeters. Means voltage drop per unit length is equal to 1.45 by 50 centimeters. 1.45 volts by 50 centimeters will be equal to 0.029 volts per centimeters. Now, what will be the voltage across 75 centimeters length? Now, let us find voltage across. The voltage drop across a standard resistor of 0.1 ohms is balanced at 75 centimeters. What will be the, if I find the voltage of drop across this 75 centimeters length of wire, then we can find the current which is flowing to this standard resistor. So voltage drop across 75 centimeters length of wire length is equal to, anyhow we know we have voltage drop per unit length. Okay, so 0.029 volts per centimeters into 75 centimeters, then you are going to get 2.175 volts. So voltage drop across 75 centimeters length of wire is equal to 2.175 volts. Then what will be the current through the resistor? Current through resistor, which is equal to 2.175. What is the resistance of 75 centimeters length of wire? Having the resistance of 0.1, right? By 0.1, you are going to get 21.75 amps. Another way of solving this problem is like this. 75 centimeters length of wire is having the resistance of 0.1 ohms. Okay, then what will be the resistance of 50 centimeters length of wire? That is, you can find resistance per unit length. Okay, first you find resistance per unit length. Resistance per unit length. Per unit length, which is equal to 0.1 by 75 ohms per centimeters. Then what will be the resistance of 50 centimeters length of 50 centimeters length of resistor will be equal to 0.1 by 75 ohms per centimeters into 50 centimeters. Okay, then you are going to get this will be 0.2 by 3 ohms. So the resistance of 50 centimeters length of wire will be equal to 0.2 by 3 ohms. Okay, you know voltage, voltage of stand cell. Okay, then you can find the current to that. Anyhow, it is balanced at 50 centimeters. Means current to that resistor will be current I will be equal to 1.45 by zero point 0.2 by 3. Okay, then you're going to get 21.75 amps. Coming to the next problem. A basic slide wire potentiometer has a working battery voltage of 3 volts with negligible internal resistance. The resistance of slide wire is 400 ohms and its length is 200 centimeters. A 200 centimeters scale is placed along the slide wire. The slide wire has 1 mm scale divisions and it is possible to read up to 1 by 5th of a division. The instrument is standardized with 1.018 volts. This is the EMF of stand cell with sliding contact at 101.8 centimeters mark on scale. Calculate working current, the resistance of series rheostat, the measurement range and the resolution instrument. Okay. Now let me draw the basic slide wire circuit diagram of a basic slide wire potentiometer. This is RH rheostat. This is battery voltage 3 volts. EW working battery is 3 volts. Okay. The resistance of slide wire is having the resistance of 400 ohms. Okay, the resistance of the slide wire is 400 ohms. 400 ohms, and it is having the length of 200 centimeters. And 200 centimeter scale is placed along the slide wire. So you are going to have scale. Scale is placed. Okay, the length of this is 200 centimeters. Okay, let this is 100. Let this is 50 centimeters. This will be unknown EMF, and this will be standard cell EMF of 1.018 volts, and you're going to have galvanometer, sliding contact, and galvanometer. Okay, yeah, fine. Working current. First one is working current, right? Okay, the instrument is standardized Okay, so switch is thrown to calibrate position. Okay, you know, right? Okay, switch is thrown to calibrate position. So we do one thing. Otherwise, let me connect these two. Now you are going to have the circuit like this. Okay, so 1.018 volts. EMF of standard cell is 1.018 volts. Okay. Now the instrument is standardized with 1.018 volts standard cell with sliding contact at 101.8 centimeters. Okay, so let this is 101.8 centimeters. So this mark is, let me write over here, 101.8 centimeters. Okay, sliding contact is placed at 101.8 centimeters mark on scale. Okay, so anyhow, I mean, it is balanced. Null condition is obtained. Null condition is, the meaning of this is the instrument is standardized with 1.018 volts standard cell with sliding contact at the 101.8 centimeters mark on the scale, means it is standardized, means null condition is obtained, balance condition is obtained when this sliding contact is placed at 101.8 centimeters scale mark on, sorry, 101.8 centimeter mark on scale placed at 101.8 centimeters. Okay, so the voltage across this will be equal to voltage across this. So voltage across this will be, voltage across this portion of slide bar is equal to voltage across this. Okay, anyhow, all you need to find resistance across a portion of this slide wire. Okay, so it is given 400 ohms is the resistance of slide wire. Total resistance of slide wire is 400 ohms. It is having the length of 200 centimeters. Okay, then what will be the resistance of 101.8 centimeters length of slide wire? Okay, so now let us find the resistance of 101.8 centimeters length of wire. 101.8 centimeters length of wire will be having the resistance of how much? 101.8 centimeters by 200 into 400. Okay, then you're going to get 203.6 ohms. Okay, the resistance of this slide wire is, resistance of this portion of slide wire is 203.6 ohms. Then what will be the current flowing to this? Working current. The current which is flowing to this is working current, IW, right? IW. Okay, what is the current flowing to this? Current flowing to this will be equal to current flowing to this, right? Okay, then working current IW is equal to, 1.018 volts by 203.6 ohms. Okay, we have the resistance of the portion of this slide wire. Okay, you know the voltage across this portion of slide wire is 1.018 volts. Okay, resistance of this portion of slide wire is 203.6 ohms. Then what will be the current flow into this slide wire? Then which is equal to 5 milliamps. Come to the second one. The resistance of series rheostat. Okay, you are asked to find RH. Okay, IW is equal to EW by RH plus total resistance of slide wire. What is the resistance of slide wire? Total resistance of slide wire 400 ohms. Okay, then from this 5 milliamps is equal to EW is 3 volts by RH plus 400 ohms. Okay, then RH plus 400, which is equal to 3 by 5 milliamps. This is equal to 600. Then RH will be equal to 200 ohms. Coming to C. Okay, coming to C. The measurement range. What is the measurement range? Maximum voltage to be measured. Okay. So here, anyhow, the working current is 5 milliamps. So the measurement range will be measurement range. Measurement range is equal to working current into the resistance of the slide wire is 400 ohms, which is equal to 5 milliamps into 400 ohms, which is equal to 2 volts. The range of this instrument is 2 volts. Okay, now the resolution of instrument. The slide wire has 1 mm scale divisions, and it is possible to read up to 1 by 5th of a division. It is given, it is possible to read, it is possible to read 1 by 5th of a division. Okay, then this will be the resolution, and you have to find the voltage for 1 by 5th of a division. Okay, first, 1 division is equal to 1 mm. Okay, 1 mm scale divisions. Okay, then what will be the voltage per unit length? Okay, now let us find voltage. Two hundred centimeters gives 2 volts. Then 1 mm gives how much voltage? What will be the voltage per division? Voltage per division. Okay, then this is equal to 1 mm by 2000 mm into 2 volts. Okay, then this is equal to 2 sorry 1 millivolt. 1 millivolt. Okay, it is given, it is possible to read up to it is possible to read 1 by 5th of a division. So resolution is equal to 1 by 5th of a division, 1 by 5 into 1 millivolt, which is equal to 0.2 millivolts. Okay, the resolution will be 1 by 5th of a division, 1 by 5th of 1 division is equal to 1 mm. 1 division is nothing but 1 mm. 1 mm gives 1 millivolts. Then 1 by 5th of a division will be equal to zero point 0.2 millivolts. This will be the resolution of this instrument. A DC potentiometer is designed to measure up to 2 volts with a slide wire of 800 mm. A standard cell of EMF 1.18 volts obtains balance at 600 mm. A test cell is seen to obtain balance at 680 mm. The EMF of the test cell is. This is unknown EMF. Standard cell EMF is 1.18 volts. Okay. It is having the length of 800 mm. It is having the length of 800 mm. Okay. A standard cell EMF of 1.18 volts obtains balance at 600 mm. Okay. When the sliding contact is placed at 600 mm, it gives null deflection. Okay. Then placed at 600 mm mark on scale. Okay. The length of this wire is 600 mm now. The balance condition is obtained when it is placed at 600 mm mark on scale. Okay, so voltage across this will be equal to voltage across this. Okay, now let us do one thing. Let us find voltage per unit length. Okay, voltage per unit length, which is equal to 1.18 volts by 600 mm. Okay, then the EMF of test cell. Now this is connected to test cell, which is thrown to operate position. Then it is balanced at 680 centimeters mark on scale. Okay. Now the voltage across this will be equal to voltage across this. Okay. Then then the EMF of the test cell, the test cell will be equal to, what is the voltage per unit length? That is 1.18 volts by 600 mm. Okay, or you can write like this: 1.18 by 600 volts per mm. Okay, into the length of this slide wire will be equal to 680 millimeters. Okay, then you are going to get the EMF of the test cell, okay, which is equal to 1.18 into 680 by 600, 1 point nearly equal to 1.34 volts. First you find voltage per unit length, then after unknown EMF will be equal to volts per mm, voltage per unit length into length of slide wire. Okay, then you're going to get the EMF of test cell. Thank you.